Ruby Community Conference organized by Visuality presents Carmine Paolino. Ruby is the best language for building AI web apps. Enjoy.
So today I want to talk to you guys about the fact that I think Ruby is the best language to build AI web apps. Whoop.
Is that Linux?
It's slide over this time, but okay, I'll do it this way.
Do you want to do it?
No, it's fine. So, I'm Carmine. I'm the founder of Chat with Work, which is an AI co-worker. And I'm also the author of Ruby LLM. I co-founded also another AI company a few years ago. And I've been a Ruby enthusiast since 2009, when I was in university. And after that, I switched to AI. So I've been in AI since 2011. And so I'm back to Ruby since mid-2024. Because Ruby was really the first love in my programming language life. But what the languages that most people think and use for AI apps, they're usually Python or JavaScript, right? And it makes sense, because Python really owns the AI space. And it owns the AI space because all of the libraries for building AI models have been built in Python. And they've been built in Python because of historical reasons. The C extensions were really easy to build. The C++ CUDA libraries were really hard to build things in for scientists. So they were trying to find the right solutions. And so everything started in Python, and then inertia happened. JavaScript owns the web, right? The premise of JavaScript being the only language that you need to learn, it's something that a lot of developers thought that it was really, really attractive. And Ruby, unfortunately, often gets passed over. And I think that's a mistake. That's a mistake because AI app development was get a data set, train a model, and build an app around it. But now, AI app development is different. Get a data set, you cannot. It's the entire internet. Train an LLM model is impossible. It costs millions of dollars. You cannot possibly do it. There's very few companies that can do that, right? So what is left for all of us is building an app around it. So this is how AI app development works now, right? You're just calling an API. That's it. Which makes the entire AI training library ecosystem, even though it's very important for AI training, irrelevant for AI app development. But why one should choose Ruby, right? Well, let's explore it with practical examples. Let's look at the top LLM libraries, LangChain for Python, AI SDK for JavaScript, and Ruby LLM for Ruby. And let's see the differences in philosophies. So let's start with a simple chat, right? First of all, you need to import not only an init chat model, but also a human message class, right? And then you call the init chat model, you pass the provider, right? Because it doesn't know exactly which provider to use by default. Then the messages, you need to create an array of messages, and they have to be, in this case, human message. You can specify it also in different ways, but this is actually the simplest and the cleanest one. And then you invoke the model. OK. Let's see AI SDK. Also, you need to import a couple things, including importing the provider classes. And then you use the provider functions in order to chat to the model, right? Again, you need to know the provider, which provider you're using. This is how to do it in Ruby LLM. You just pass the model, right? We know exactly which models are from which providers. And it's also in one line of code. I'll show you that in a second. How is that possible? But let's talk about multi-turn conversation, right? This is the most likely thing that you're going to build. You're not going to just chat with an AI once and then leave it. And unfortunately, they don't make it that easy. So you have to import a human message class, an AI message class, an init chat model. Then again, you need to specify the provider. You need to pass this human message class inside an array. Then you need to invoke the model, get the response from it, append to the array of messages, and then append another human message, and then invoke it again. OK. Let's see if AI SDK is better. No. You need to do exactly the same things, except with probably worse syntax, in my opinion. Let's look at Ruby LLM. You just need to instantiate a chat, and then use the same chat to say first hello, and then to ask to tell me more. That's it. We keep track of your messages. We keep track of the messages from the provider. You don't need to keep track of them yourself. Conventional configuration. Streaming. OK, let's look at streaming. So we're doing the same thing. You guys know now. And we're going to iterate through chunks. This doesn't look too bad, right? But what about if you want to have thinking, like reasoning from the model? You want to print it out. Well, you need to filter all these reasoning chunks from the rest of the chunks yourself, and you need to actually do it in that way. Why? And this is in AI SDK. Same thing. We're filtering by looking at the part type. And this is how to do it in Ruby LLM. You just have a block, and then you can print chunk.thinking and print chunk.content. Ruby has all these beautiful abstractions. For example, print doesn't do anything if it's nil, right? So if thinking is, there's nothing in thinking, it's not going to print anything. Really, really beautiful. This is why I came back. Multimodality, right? This becomes even worse. So in order to pass images to models, there are two ways. You can pass a URL, or you can pass some base64 encoded image, right? And now we're getting into the weeds, because it turns out that LangChain wants you to create a whole message object with a type image and a base64 image. So you need to create that base64 yourself. You need to also download the image. This frustrates me just by seeing it, guys. And this is how to do it in Ruby LLM. As you can see, we're just instantiating a chat, and we're asking something to the model with an image. The API reads like you want to, or at least I want to. And now, what about passing multiple things, right? Well, we can pass an array. And all of these file types are recognized if they're recognized by the model itself. Very, very simple. And this actually made me laugh. So the CEO of Vercel tweeted very proudly that his AI SDK was like the best thing in the world, that chatting with a PDF is super easy with 20 lines of code. I don't know if you guys can see the code, but it's still 20 lines. And this is what I commented. As Obi said, be bold, right? So this was actually the first syntax of Ruby LLM 1.0, which came out March 11th last year, right? It's actually 1 year old, so happy birthday, Ruby LLM. And you can see there are curly braces. We don't do that anymore. We just pass the file. And we actually figure out which file type it is, thanks to other gems that the community has built. In this case, Rails itself. So there is Marcel that figures out the file type for us, regardless of the extension. OK, what about tools? This honestly looks quite nice, right? This is in Python. There is a nice decorator. And this basically wraps the entire function. If you guys don't know, the decorator is in Python. And so it can read actually the documentation there, and the documentation turns into a description. Very, very cool. But then you still have this, like this syntax with curly braces, and you have to know what a role is, what a user is, etc. And then invoke it this way. Then we have AI SDK. And now you have to import even more things, apparently, including Zod. And in this case, we're using Anthropic, so you have to import that. And you have to create an array of tools and all of that. It's very complicated. And this is in Ruby LLM, which is quite simple. So basically, all your code is inside the execute function. And this, if you remove the ellipses there and you actually put it from the documentation, you can see this exact example, it would actually work. And it will tell you what's the weather, in this case in Bangkok. What about agents? So this is a new feature in Ruby LLM 1.12. And, well, you have to import all of this, create a tool, and then create a React agent, and then add the messages, right? Same thing in AI SDK. I guess you can figure it out. And this is an agent in Ruby LLM. You just specify the model, instructions, which I think is a better name for system prompts, and you specify your tools there, and then you just ask a question to it. And this makes what we already have been doing for a long time, which is already agents. By the way, agents are just LLMs with tools. I can expand more about that later if you guys want, outside. And I also have a blog post about it. But now you can wrap it inside a really nice class, and you can reuse them as much as you want. So basically, Ruby LLM is one single API for all the 13 providers that are the biggest providers out there. Right now, actually, the model registry has 1,170 models. And every OpenAI compatible provider is also compatible. And all models from Hugging Face and Model Scope and Ollama, which are, covering pretty much everything in the local model space, is also compatible, thanks to the Ollama integration, but also the GPU Stack integration that gives you all of that. GPU Stack is running a bunch of different local inference servers, like VLLM, and many others, even from NVIDIA. So how do you change a model in Ruby LLM? Pretty simple. You change the string. Why? Why you should change a string, right? Why not pass like a provider, right? Because if you have a real app and you want to change the model from just a selector, where do you store all the providers, right? This was one of the first questions I needed to answer for myself. And I started thinking, I need to have a model registry. And then this whole thinking started. I started to look into how to modify the existing things. I didn't like what I saw. So I was like, how hard it is to actually build my own. And then fast forward, a month later, last year, I built Ruby LLM. So it started because of the model registry. Well, you can also specify a different provider, because some of these providers have the same models. So, for example, OpenRouter pretty much has all the models you want for just like a 5% fee, I believe. And in this case, if you want to have Gemini 3 and you just have an OpenRouter key, you can just use it like that. Of course, Ollama as well. And so the model registry has all of these models. And it's super helpful also for knowing what's your context window size, which is really, really helpful if you want to know how much of the context window is already used. For example, in the status bar chat with work, I have like how much memory, I call it like that, you've used in this specific chat. And also, what's the pricing, right? It's also really important to build your clients. How do you build your clients if you don't know pricing? Well, before this model registry existed, you had to go to the documentation website, and you had to actually check the pricing there, copy it in some spreadsheet, make some calculations, and then figure it out later, after the fact, after they've already spent the money, how much money each of them spent and how much you should bill them. Crazy. No, code should do this, right? And so you can price your app, you can refresh with the latest models anytime, and you can explore them by provider, by capability, because also this is just a partial view of the model registry, but we also know exactly which capabilities they have. So for example, some of the models are embedding models only. Some of the models can also input, can have in input images, PDFs. We have all of that information, and you can explore it really easily. So for example, vision is how we call it when a model can see images, and you can just select it like that. And I'm super thankful for models.dev, which is made by open code, which basically enriches the data that are already scraped from the models APIs from the providers. But the models API from the providers, they just add the list of models, pretty much, right? And so how do you price your app? Well, you need to know the usage, right? And the thing is, if you want to do that in LangChain, you'll have to parse it yourself. And this doesn't make any sense. So in GPT-5 Nano, so in basically the OpenAI provider, you will find it here, the amount of tokens you've used, right? Some for the prompts, some for the completion. And then you switch provider, and you switch to Anthropic. And now what? Where is it? It's here. OK, let's make another if statement. Oh, and now you want to use Google, and you try to find it, and it's nowhere to be found. What? So instead, again, in order to have like one single API for all the providers, we actually parse these things for you. And we also have tokens for thinking, input, output, caching, etc. And it looks the same. Of course, we don't stop at chats. There's a lot of other things that AI providers provide. And you can do a lot of things with one line of code, thanks to convention over configuration. Now, how does it work? Well, we simply have a default model. So in chat.ask, for example, the current default model is GPT-5.4. And then you can paint an image with another image model. You can create embeddings from text. And you can moderate content. And you can transcribe audio. But OK, cool. You know, this is all Ruby, plain old Ruby objects. But you know, really what we want to do is create Rails apps, right? We want to actually make businesses. This is kind of our ethos. And so I made a Rails integration that can go from 0 to chat UI in less than 2 minutes. Actually, in 1 minute. I reshot the video. Let me show it to you. It goes really quickly, huh? So first, we're creating a Rails app. Some of you may have seen this today. Then we're adding Ruby LLM, trunk versions because they have some new updates. And then we're just using the install generator. It's going to create a lot of the actual craft that you need to have for plumbing, such as all of the messages models, the chat models, the tool call models, and the models, so LLM model. And then what you simply need to do is to add your OpenAI API key, because that's the default provider. And we already have a generator in that, and in the initializers. And install the chat UI. And you can already start your server, create a new chat. And this was 1 minute. In 1 minute, you're chatting. And as you can see, we're streaming the tokens, right? And we're also using Turbo in order to do that. So everything works with default Rails. It really likes to please you, the LLMs. And there is a little bit of an interface for models as well. So you can scroll all of the chat models in the model registry. You would think like, oh, this looks complicated. Maybe it did complicated code. Well, actually, it's pretty simple. So this is the magic that does the streaming from the LLM, and it calls the LLM. So first of all, we're finding the chat. This is a chat response job. This is what gets called from your messages controller, your chat controller. And we create the chat beforehand, right? And then it's using chat.ask just in there, passing the content, which means the prompt from the user. And then we're streaming the tokens inside the chunk, right? And we have a broadcast append chunk that actually appends the chunks inside the correct partial in the Rails integration. And you can see chat messages.last, why we should have that. Well, this is because in one single ask call, you can have multiple responses from the LLM. And this is what people will say it's called the agentic loop, but it's not really a loop. It's just the LLM going back and forth with itself. Because every time it returns a response, you're sending it back to the LLM, especially after a tool response, for example. And so we need to know exactly which message to append things to. And then this is from the controller. You know, you just create a new, when you're creating a new message, you're taking the chat ID and you're passing the message content to that, and that's it. And then the models are also very simple. We just have everything inside the access chat, access model. That's pretty much it. Cool, but what about scaling, people say, right? Well, I'm glad to say that it also scales. And I think this is thanks to not only async, which makes it easy, but also to Ruby itself and how easy it is to make fiber-based applications. But let's talk about why exactly it is scaling with async specifically. So the reason is actually the difference between the classic job queues and async job. So in a classic job queue, like solid queue, sidekick, etc., you have a setting for the max amount of workers, and that's a required setting. And so at the 101st chat, if you have 100 workers, it's going to wait. It may wait minutes, more, if you have complicated tool calls and chats that run for an hour or something. And also, each single one of these workers needs to have a connection to the DB. Now suddenly your connection pool skyrockets. And on top of that, you have all the problems with threads, which are simply about the fact that, well, threads are scheduled inside the operating system, and that means a lot of like switching costs, a lot of context switching, a lot of memory also, especially for shared memory. Shared memory, I think, is like 8 megabytes in Linux for each thread. Instead for fibers is 24 kilobytes, and it's inside the Ruby interpreter. And also, and more importantly, all these workers, they're not doing anything. They're just waiting for some tokens. And in the time scale of a CPU, that waiting is not seconds. It's like years for us compared to what we would experience, because the CPUs are really fast. Instead, with a sync job, you don't have a max worker setting that is required. You can put it in there if you want. And if you have 100 fibers that are running 100 chats, you can actually reuse the DB pool. And this is because of how fibers work. So fibers, they are collaborative concurrently. So they're collaborating with themselves to have this concurrency facade. But really, they're running one at a time, right? Really, really quickly. And therefore, it's just like one single interpreter that can use, in theory, one single connection In practice, you may want to use a little bit more, because actually what is happening is I/O multiplexing, so these connections may not finish in time while you're having another fiber, so add a little bit more, but you're not going to add 100 of them. You're maybe going to add like 10% of that. On top of that, fibers, the context switching is a lot faster, and in Ruby 3.4, with a simple web server, the amount of requests per second just skyrocketed. Look at the difference, threads-wise and fiber-wise. The same kind of code. This was actually made, there was a benchmark made by Samuel Williams, which is also the author of Async. And by the way, Async is now used at Shopify. So Falcon became now the default web server at Shopify. So if anybody is doubting that this stuff scale, yeah. And as I said, jobs, so basically it's collaborative concurrency because you need to give, each fiber needs to give the permission to the next fiber to continue working. And in Ruby, it's better than other languages because the Ruby interpreter knows when it's doing I/O. So every time, you don't need to actually write the code, please give the yield to the next fibers, but the Ruby interpreter knows that it's doing I/O, therefore it auto-yields. And that means that we don't need to write any async await keywords anywhere in our code. So actually, I didn't have to do one line of change in Ruby LLM in order to have this scalability. It was awesome. And also no wasted resources, because now your CPU is actually using all of its power. It's not just waiting for tokens randomly. OK, great. It also gives you a lot of power if you want to have multi-agent orchestration. And it makes it really simple. I can't believe that this is 13 lines of code. And it is actually 4 different agents, 3 of which are going to run at the same time, and 1 of which is going to summarize after that. So let's say we want to have a security review, a performance review, a style review. How do you do this? Well, really simply, you can use an async block, and basically you need to create 3 tasks, right? And we can map them inside the reviewers array, and then we simply call the review. And in this case, we're passing, the type, which is security, performance, or style, and then the code, right, which came from the parameters. And then we're returning the content. And then we're returning the review and type to the LLM, right, at the end. We're waiting for all 3 to finish. So once they're all 3 finished, we can actually summarize the code. That's it. This is incredible. But why? Why is this only possible in Ruby? Why can only Ruby have this level of attention to detail and quality of the code? In general, I'm not just speaking about Ruby LLM. We've seen Rails. We've seen other gems. They're all looking really, really good. Well, there's a few technical arguments. Blocks are a language feature, not just a function. This is Python. And in the async generator, you need to call a function. And this becomes a little bit more cumbersome to deal with, especially with async and await keywords plastered everywhere. In JavaScript, also, you have the same kind of concept with async await. But in Ruby, you can simply have an implicit block without extra syntax, and you still get also all the benefits of everything, fibers, threads, whatever you want, without changing your code. And the implementation of all of this is really simple as well. So this is actually from the implementation of Ruby LLM. And as you can see, in the ampersand is passing along the block, right? And so I can wrap the block with other things for streaming, for example, without having to make really complicated functions that go inside and do introspection. And also we have class macros, symbols, and optional parentheses. So things look kind of like pseudocode. And it permits the creation of DSLs like these. which get implemented by very simple code. So it's joyful all the way, end to end. On top of that, we have open classes, right? Sharp tools that we can hurt ourselves with, but we love it because we can do this kind of stuff. We can monkey patch our classes and add class methods to them. We can add class attributes, define methods, whatever we want. And this is why. Because code aesthetics and programmer happiness are the fundamental principles of Ruby culture. Let me give you a case study. So there is a library called NodeLLM, and it's basically a JavaScript port of Ruby LLM. And it actually looks pretty decent. I really like it. So you import NodeLLM, and then you just do NodeLLM.chat. You don't have to know about the provider. And then you do chat.ask. You need to await, so that's OK. And then you can stream it like that. Very nice. Let's look at NodeLLM's reception. It's kind of sad. And these were the only comments I could find on Reddit when the original author, posted about it. The only comments. So 0 upvotes for the people that are just in audio. 0 upvotes in both the JavaScript and Node communities, and 14 stars of GitHub. We're not talking about the next day. We're talking about months later. And these were the only 3 comments. Crazy. Instead, look at RubyLM's reception, especially with the lens of, like, this is the community that has received it this way, right? So it became #1 on Hacker News last year, in 2 days. And then from the launch, 1 week later, we had 1,700 stars, and now we're sitting at 3,700 with 5.4 million downloads, right? Because everybody appreciates the code aesthetics that we have in Ruby. And it's been trending, and also has been receiving quite some nice feedback. And now it's used on many, many companies, and also 37 Signals actually chose Ruby LLM last year. And also the Ruby LLM ecosystem is growing, so we have a lot of other gems, some of which have been built by some of you in the audience. And they can do various things that Ruby LLM doesn't implement. For example, Ruby LLM monitoring is a Rails dashboard for cost, latency, and errors. Ruby LLM instrumentation is active support notification events for Ruby LLM ops. We have semantic router, semantic cache by Chris that can do semantic routing for agent tool selection and semantic cache for repeated prompts. We have Ruby LLM MCP by Patrick Weiss for MCP support for structured workflows. We have Ruby LLM schema, which actually became a dependency of Ruby LLM, which is a JSON schema DSL, which we co-designed with Daniel Fries for structured output. We have Ruby LLM templates, which kind of repeats what now Ruby LLM has in terms of prompts, and in a different way. And Ruby LLM skills that adds agent skills support to Ruby LLM, and also evaluation frameworks like Tribunal, and even an OpenTelemetry observability for LLM apps. There is an OpenPR in OpenLLM-metry, and at the same time, Thoughtbot actually came up with its own gem that it can do OpenTelemetry support for Ruby LLM. So there is a growing ecosystem, and I'm also shipping a lot of things. So what's coming for 1.14, which some of you have seen today at the workshop. So we're going to have a Tailwind chat UI. It's going to look a little bit better than the scaffolding style chat UI, which was on purpose ugly, but also ugly. And generators for tools, agents, and schemas. And also, finally, Rails conventions for your AI code so that you can all follow this convention. We all love that. I've been using this in Chat.Work since the start of Chat.Work. I just ported the code from there. So we can all agree on the same things. And it's going to have app agents, tools, schemas, prompts, and also each single message gets its own partial. And for your tool calls, if you're creating whatever tools you put inside app tools, is also going to search for tool call and tool results partials inside your views. So you can have really nice UIs really quickly. So, in conclusion, I think Ruby LLM, if I say so myself, makes LLMs simple and elegant. But let's not forget, Rails is the fastest way and probably the best way to ship real web apps really quickly. We're all here for it. And also, Ruby has really the best developer community in the world. I cannot thank you enough by how much you've been embracing my project out of nothing. And so I think that Ruby's moment in AI is here. So go ship AI apps and share them so we can all tell the world that we have that. So thank you.
So many things to wait for. So we're going to have many things. So I guess you have questions, and Carmine wants to answer those questions. So we'll take a few from the audience. Who here is using a Ruby LLM in production?
Oh, wow.
Okay, awesome. Who here built their own chat UI? Oh, impressive.
Nice.
That's good. Who's thinking about switching the chat UI to the new thing? Oh, okay.
Don't worry, it's just
no
scuffled.
Nothing? Okay.
I didn't hear you talk too much about MCP, so I figured I'd give you an open-ended question about, besides the built-in tools, which are a little bit, I feel like, antiquated at this point. How are you seeing the whole MCP picture play out? There's fast MCP, action MCP, etc.
Right. Great question. So I think MCP is a really great crutch. So whenever you're starting to build a new web app, right, you want to connect it to Google Drive, you want to connect it to another Postgres server, you want to connect it to many, many things, right? Because in the end, tools give the LLMs the most amount of tools in order to do something useful. And MCPs just are basically like a black box with a lot of tools that you can connect to it. The problem is you're gonna use all of your context window really, really quickly if you start to plug in a lot of MCPs inside. So I think MCPs are cool for the beginning when you're starting to use all of this. But if you're running into context window problems, especially, it doesn't even have to end the context window, but it can be also just by using 10%, 20% of it, you can already run into context rot, what it's called. So the LLM is basically becoming dumb after that. And your tools are some of the first parts of your context. So all of the rest of your conversation is going to become a little bit dumber. In that case, which is most cases, I think, when you're actually serious about building new things, you should probably build your own tools, because then you know exactly what goes into the context, right? And you're not giving that permission, from somebody else that built that MCP. And are you actually reading, the description and the params description and all of that gets into your context window? Probably not. So my problem with MCPs is that it's really cool at the beginning. You can get started really quickly. You get like these first sparks. But then you should probably, build your own tools and really be careful about what goes in your context window.
Okay, another one here.
Hey, thanks for your jam and great speak. I have a question for you about database connection multiplexing in Ruby fibers. I mean, I imagine that a fiber might yield to another one during database transaction, which was not committed. But then again, you can create a fiber level isolation in Rails for active record connections, but then you won't use the, each fiber will create a new connection Am I right? How have you overcome this problem?
This is for the maintainers in Rails and async, to be honest. I have no idea.
Oh, okay, thanks.
I have a question. What are your thoughts on running Ruby eval with things that are coming from the LLM?
Oh, yeah. That was the #1 comment on Hacker News, actually, on Ruby LLMs 1.0 by Greg.
Of course.
Yeah, Greg Molnar, by the way, if you guys don't know him, is a security expert. And, well, it's terrible because you're passing everything. So the LLM can basically write whatever code, and then Ruby is going to execute it, right? And once you have Ruby executing anything, you can do anything in your machine, pretty much, right? So terrible idea. Please don't do it.
I think I understood what you said, but I got to violently not violently, peacefully disagree with you. I recently wrote a post about code mode, first of all. There are ways around whatever security issues. And actually, there's a really cool mRuby-based Ruby solution to being able to...
Enclave.
Yeah, Enclave, which is... So there's innovation and very interesting kind of development in this space, you know.
I will still not run eval. I'm not sure about Enclave exactly how's the sandboxing model, but it sounds such a terrible idea to run eval in Ruby.
I'm using extensively and it works fine. Yeah, we can talk in hallway track about
I'll
it.
send you, Greg.
I'm going to stop that here. Do you have any other questions, non-eval related? Okay, another one.
Okay, I have a question about model. Why did you named the model the model?
Why not?
Is it a reserved word?
It's not a keyword that we cannot use.
Okay. All right. This
LLM model is so ugly. Like then you have LLM. It's not properly capitalized. Blah.
all right. All right. I have doubt about it, but
Yeah.
okay. Thanks.
Cool. Okay, you'll have your time during the breaks and tonight to badger Carmine to tell you his secrets. You have another 10 minutes for a break, and then we're gonna come back with the last 3 lightning talks. Thank you.
Thank you.